Good morning, everyone. So I asked you to have a go at question 5. I'm going to be going through that. At the moment, when I'm recording this, this is still only the time before you would have had your chance to do it. So I haven't yet had a chance to see how those of you got on who did it. But I'm going to go through it anyway because I think it's important for the stuff that we're going to be doing this lesson that we do have a look at it. Before we do, we've got yesterday's starter as well, the battleships one. I'm going to show you the answers to that, and then we can crack on. Right, now I don't know how much of a go you had at this, but it was really quite a tricky one. And the key for me was when I went back and I reread that it said ships are surrounded on all sides by water. So you can see that I've been using a pencil here. And what I did was, for example, where I'd got that cruiser, I put crosses all around there where I knew there couldn't be a boat. And anywhere there was a line with a 0 in, I put crosses all the way down there. Because I'd already got 2 in this column, I put crosses all the way down there as well. And once I'd done that, I'd knocked out most of the squares where anything could be. And so all of a sudden, the only place that the big boat could be was there or there. And then realizing because of I can't remember why, but anyway, thinking it through and just using a pencil where I wasn't totally sure, that did help. And I don't think I've made any mistakes. Let me know if I have. I asked you to send your effort on this to me, so see how you got on compared to me, and I'm going to just set it out, take the time thinking it through the way that I would. Now what I would do is I would make a schedule of all the different sides I've got. First of all, before I even draw the net, I'm going to count just how many sides I've got. I've got 1, I've got the front, I've got the back, that's 2. 1, 2, I've got the top, I've got the bottom, 3, 4. I've got the left, I've got the right, 5, 6, but I've also got 2 there. So I've got 8 sides because of this L-shaped bit has put 2 extra sides in than I would normally have on a rectangular prism. So 8 sides, and 6 of them will be rectangles and 2 L's. So I might even put that dot down there, I think, because I know that's 5, that'll be 3 centimeters. So I'm going to do the area of the L by doing 7 times 3 equals 21, and 5 times, that's 3 high, isn't it, equals 15. So I've done, so the L equals 21 plus 15 is 36 centimeters squared, and I don't need to worry about that anymore. And because I know I've got 2 of them, that's going to give me 72 centimeters squared. And then I know it's just the other 6 rectangles for me to be thinking about. So if we start with, I think what would be the easiest thing to start with? I reckon going from the base. So I'm going to do the base, which is 8 by 10. So if we call that the 10 bit and that the 8, off the 10 there, if we go for the, actually I'm going to call this one the 8 because that's the way I'm looking at it. It's a bit less confusing that way. Then I'm going to come from down the 8 by 10, so this is the base. And then I've got this bit here, so that is an L, that's going to be 7. And then I've got 3 at the top. So that's 3 and that's 5. Then I'm going to have an L the same above that. And then off the base, this is 10 wide, this is coming up 3, isn't it? Because that's that bit there. Then it's going wrapping around there and it's going along another 5. Then it goes up here. Now if that's 3 and that's 7, this bit from there to there must be 4. Now how many, I said 8 sides and 6 of them 6 rectangles. I've got a feeling we might be able to get all the rectangles here go in a row, so we might be able to make one long rectangle out of them. And then up at the top here, that's another one that's just 3 wide. And then we go down the left hand side, and that is going to be 7 wide. So we've got 1, 2, 3, 4, 5, 6 all going across there. And I know, just to come back again, that is 10 wide, isn't it? And then the rest of these steps are all going along, and we've got 7, 3, 4, 5, 3, and this one here was 8, wasn't it? So if we add those together, 8 plus 3 is 11, plus 5 is 16, plus 4 is 20, 23 plus 7 is 30. So I can say that that whole length there is 30. So the 6 rectangles all together are going to be 30 by 10. So we can do them as one rectangle, which is 300. And then I've got the 2 L's, which are 72. 300 add 72 gets us to 372 centimeters squared, and that's the whole thing done. So just as a reminder, I started by thinking it through, thinking about how many sides I'd got all together before I even started trying to draw the net. I worked out the L shape because although it's the most complex one, it's right in front of me and it's simple. I dealt with both of those, put them to one side, and then I drew out the net. And as I thought it through, I realised they're all going in a line, those rectangles, so I could make one massive rectangle, which I can work out in one multiplication of 30 times 10. And then I added them together. So we've just got 2 more questions we're going to do today. We're going to take our time over them. I'd like you to pause it. I'd like you to read the question and have a go. And the first thing you're going to need to do is work out the surface area of the cuboid. So the surface area, we can draw the net, or we can, when it's a cuboid, it's a case of remembering that you're going to have double of each one. So the front, if I look at the front, it's 100 by 50, 100 times 50. Not even going to work it out yet. Then if I look, and the front is the same as the back, so that's going to double at the end, so I don't worry about it yet. Can I find another different one? The sides are 40 by 50. And then even without looking at that, if I look, I think I've used the 50 twice, I've used the 100 and the 40 only once. So the other one is going to be the 100 times 40, and that's the bottom, and then we'll also need it again for the top, won't we? So I'm just going to do these 3 multiplications. 100 times 50 is 5,000. 40 times 50, well, 4 5s are 20, plus the 2 zeros is 2,000. And 100 times 40 is 4,000. Add those all up, 9, 10, 11, and then times it by 2. So we just need the whole lot again to get the other 3 sides, and that's going to give us 22,000 centimeters squared. Now, there's 4 marks for this question. You're going to have got 2 for doing that already. Then each pot of paint can cover 6 meters squared. So how many pots are we going to need? Well, you're going to get another point mark for dividing by 6. Even an attempt to divide by 6 may get you a mark, even if it goes slightly wrong. 6 doesn't go into 2. Carry the 2. 6 into 22, because it's 0 remainder 2. 6 into 22 goes 3 6s are 18, and a remainder of 4. 6 into 40 goes 6 6s are 36, with a remainder of 4. 6 6s are 36 with a remainder of 4. 6 6s are 6. So that's going to keep on going forever. So it's 366, and 2/3 of a pot, to be honest. Now, is that the right answer? And it's not quite. Hang on. Hang on. I've made a mistake here, haven't I? I've made a few mistakes here. I've gone far too early on my dividing by 6, and that's an awful lot of pots. That's what I was starting to think. When it's so many pots, what is it that may have gone wrong? And I've just looked here, and each pot can cover 6 square meters, and we've got centimeters squared here. Now on top of that, I've also misread this question because it's saying 5 of these boxes. So this is one box that we've got for there. We need to multiply it by 5. So if I times 22,000 by 5, well, 22,000 times 10 is 220,000, and then if I half that, I get 110000. So I've got 110,000 centimeters squared to be painted, but I want it in square meters. Now remember what happens when we looked at this a while ago. Consider your square meter is 100 centimeters by 100 centimeters. So 1 square meter is 100 times 100, which is 10,000 square meters. So it's going to take 10,000 square meters to make that. So if I turn this into, to turn 110,000 square centimeters into square meters, I need to divide by, so that's my square centimeters. I need to divide, but I put too many zeros on there, by 10,000, because 100 times 100 got 4 zeros. So that means moving the decimal point back 2, 3, 4 times. So that's giving me 11 square meters. Now 11 divided by 6 is a bit easier. It is 1 remainder 5, 1 5/6 of a pot. But how many pots would I need to buy? I can't go in and buy 5/6 of a pot. They love asking this, and to get the full marks I would then need to write 2 pots. If you just write 2 on its own as a total guess, you don't get anything. You've got to have 2 with the working that's going on. Okay, now the final question here, this is possibly this is going to have to introduce a couple of other things to you, but make a sketch of it and see what you think. Can you remember anything about the area of circles? And think about what the net is going to look like of a cylinder. Right, so a cylinder, the net is going to be, if you imagine I was to put a cut down there and then peel that off, what shape would it make? It's going to have a height of 1.5, and then all the way around there is going to be straight edges as well. So the net of a cylinder looks something like this. The curved edge around there, if it was made, if you cut it through and rolled it out again, would actually be made from a rectangular piece of metal there for the tank. And then you're going to have a circle at the top and another circle the same size at the bottom. Now, what we need to think about is, we know this length here is 1.5 meters, and we know that distance there. How can we work out this distance here from that? Well, this distance here is called the diameter. And this length from here to here is the distance all the way around the circle, which is called the circumference. And it's going to be a bit more than three times what the diameter is. And there's a special number that links us to it. So we can say that we know that the circumference is equal to pi d, where d means the diameter. And you're going to need to know that when you walk into the exam room as a formula. So we're going to have circumference equals pi times the diameter. So the circumference equals pi times 50, which you can put into your calculator. Now, if you haven't got one of these already, I recommend you getting one. You can get them on certain sort of websites that deliver all sorts of things, all from Tesco's, I believe, as well. They're not that expensive, and these will get you lots of marks in the exam if you know how to use it starting from now. So if I turn it on, I want pi. Now, anything which is in this color here, and this here is the pi symbol there. In order to get that, I need to press shift, and that, because that's the same color for the word shift there, means if I press that button, I will now get that function. So that's given me pi times by 50 equals, and initially it just tells me 50 pi. I can change that by using S to D, but whilst I'm working it all out in the calculator, I'll just keep it as 50D. 50 pi, I mean. And that means that the area of the rectangle is going to equal 50 pi times 1.5. So I'll put that into my calculator, and that tells me 75 pi, because 1.5 50s are 75. So we'll just keep it as 75 pi for now, because then we don't have to write as much other stuff. If you want to turn it into a decimal and write it all out closer to however many decimal places you can, but you're just wasting your own time. Right, so now we've got two circles that we need, and the area of a circle, and if you can remember the formula for this, you would have been taught it before. The area of a circle is pi times the radius squared, pi r squared. And if you know the diameter, the radius is half of it. So the diameter is 50, so the radius will be 50 divided by 2, which is 25 centimeters. Now, we got into trouble last time because we were working in meters and centimeters, and I've done it again, haven't I? Because I've done it times by 50 there. It should have been 0.5. So this 50 should have been 0.5 meters. I'm going to change it into meters now, because that's what we're dealing with in terms of paint cans. So if I put 0.5 in there and 0.5, when I times that by 1.5, that's going to give me, instead of that 0.5 as well, 1.5 times 0.5, just check, it should be 0.75. So we've got 0.75 pi, and the radius is going to be 25 centimeters, which is 0.25 meters. So the area of a circle is going to be pi times 0.25 squared. And you put that all in like this. Shift pi times 0.25 squared gives us 1/16 of pi, it says. So just write that as that. You've got the calculator with you. Now we want two circles, so that's going to be 1/16 pi times 2, which is 1/8 of pi, and we're adding that to the area of the rectangle, which is 0.8 0.75 pi which gives us, actually I'll put it into the calculator with you, so 1/8 shift pi plus 0.75 shift pi, and it doesn't matter if you mix up fractions and decimals in the calculator, it can handle it, gives us 7/8 of pi. At this point, this is the total surface area, so I am going to change this into a number that means something. So 2.75 square meters to 3 significant figures, and we need to know and that's not as much as the 4 square meters, but again they've told us we've got 4 tanks, so this is 1 tank equal to that, times by 4 tanks will equal 10.9955, it says. So if we divide that by 4, we get 2.75 pots, and you can't buy 2.75 pots, so your final answer needs to be 3 pots. And then I think that's as far as we're going to go today. We will pick this up with some more look into working out volumes of prisms next time.